Hi, welcome to math class. This is section 5.2, standard and point slope form. Up until now, you thought all linear equations were written in slope-intercept form. Surprise, not all the time. Okay, today's secret word, video secret word, will be put together by writing down the red block letters that you will see. So write down the letter A. Okay, here's the slope-intercept form that you know and love. Okay, you guys are all real good at that. These other two forms have their purposes, though. Here's standard form. You will use this a lot when you're solving systems of equations, and I'll explain what it is in a minute. And this is point slope form. It's a little unwieldy because it's got a lot of letters going on there, but it's actually a derivative of the slope formula. Some people like it to be used in place of the slope-intercept form. Not a huge fan, but I'll show you how it works. Okay, so this is a lot of print on one page. Basically, what they're showing you here is that they've given you a point and a slope, and they're trying to explain that the point goes here and here, the x and y go there, and the slope goes here. Okay, these are the steps. If they give you the slope and a point, then you only have to do two steps. All right, you take the x and y they give you, and you put them into the equation. And then you take the slope they give you and you put that in the equation, and then you've got your point slope form. If they give you 2 points, the first thing you're going to have to do then is find the slope they didn't give you. All right? Then do these other 2 steps. Basically what that says. All right, so here's an example. This is where we really get to explore with this. They've said, write an equation in point slope form for the line that passes through -2, 7 and has a slope of -3/2. All right, so when you're using the point slope form, the first y and the first x always stay y and x. You replace the second ones, okay? And then the m you replace with slope. So we replace this y with the y coordinate 7, and we replace this x with the x coordinate -2. Okay, now notice the slope form, or this formula, both of these are minuses. That's part of the formula. And it has to be that way. The only time it's going to change is if you have a negative coordinate like we have with this 2. Notice when we put the -2 in here, now we have minus negative. All right, we don't want to have minus negative. So what you would do is you would simplify this, -3/2, and it would be x plus 2. So if you're looking at an equation in point slope form and there's a plus, that means the original coordinate was negative. Okay. Now, how would you graph this? Well, you would plot the original point, -2, 7. 1, 2, 3, 4, 5, 6, 7. Right there. And then use the slope, -3/2. Down 3, right 2. Down 3. 1, 2, 3, right 2. Down 3, right 2. And a slope dude would say, that is a nice negative. That's what he'd say. That's how you do that. Here's the check. Determine the equation in point slope form for the line that passes through 7, 5 with a slope of -3. They've filled out everything for you except for these 3 numbers that you need to put in. Okay, this is always minus and this is minus. These are both positive, so those are going to stay minus. The 7 is the x coordinate, so it goes here. The 5 is the y coordinate, so it goes here. Slope is -3, and that goes here. Okay. And then, of course, graphing this one's a little tricky because they went to this, I'm going to jump by 2's graph. We have to graph the point 7, 5, which would be 7, 2, 4, 5, about there. And then use our slope of -3 to find another point. So from here, you would go down 3, 1, 2, 3, right 1, right there. And another negative slope, another nice negative. That's kind of a terrifying negative, if you ask me. That's pretty steep. I would not want to ski that. It's not a bunny hill. That's what they call the beginner hills, bunny hills. Okay, write an equation in point slope form when you're given 2 points. This takes an extra step because you've got to find the slope first. So they've given you the 2 points. They filled in the slope formula, arrived at a slope of 4/4, or reduced version is 1. So now you can write the equation. You can select either point. It looks like they want to use this one. All right. And we have a slope of 1. And we're just going to fill in, okay? The y-coordinate is -3, so that goes here. And the x-coordinate is 6, that goes here. Now, see, they've got the simplify step because they don't want that minus and negative thing going on there. So the final version of this is going to be y plus 3 equals 1 times x minus 6. Now, you might be tempted to leave the 1 off, but in order for this to really look like point slope form, I'm going to put it in there. And it's supposed to have the slope there. Okay, so here's our chance to do it without help. Have we missed any letters? There's a D. Let's see if we missed any other letters. There's a D. Did you get that D? So you should have 2 D's and an A. 2 D's and an A. Now, where am I? There I am. Okay. So first thing we have to do is find the slope. So second y minus the first y over second x minus the first x. Keep change. We get -20 over +5, which gives us a slope of -4. Well, going over here, I can see that we can right away eliminate B and D because they have the wrong slope. Right? Now, which one of these is correct? They're using the point -11, -2. Notice they're both negative. Here's what this is going to look like. Y minus -2 equals m, which is our slope, -4, times x minus -11. What happens when you have minus and negative? That happens. So what we're looking for is an equation that says y plus 2 equals -4 times x plus 11. Because both of the coordinates were negative, so both of these signs have turned positives. So A is the correct answer. This one has a negative here and a positive here. Not right. This 2 is negative, so that one, not right. Are you having fun yet? I'm having a great time. Change to slope-intercept form. Changing to slope-intercept form means they want it to go back to the y equals mx plus b from point-slope form. Well, the first thing we've got to do, we're trying to get y by itself on the left, and then the x term on the right, and then the constant on the right. Well, here's what we'd do. We'd get rid of these parentheses by distributing. -2 times x is -2x, and -2 times -6 is +12. Okay? Now, we need to get y by itself, so we would subtract 4 from both sides, and that gives us y equals -2x plus 8. Now, here's our chance to do it. We're going to distribute this -1/2 to both of those. That will give us y plus 3 equals -1/2 x, and -1/2 times -8 is +4. Then we subtract 3 from both sides to get y alone, and that gives us y equals -1/2 x plus 1. Good times. Yep. Okay, and now in true reveal style, they're going to throw a word problem at you. Really, they're just giving you another problem with 2 points. You have to find the slope because they didn't give it to you, and they're hiding them in a word problem. Nadia's book club is ordering new novels. She knows that the total cost of 5 books is $61.25. That's your first point. 5 books, $61.25. And 15 books, your second point, cost $159.75. They're not the prettiest points. So the first thing we have to do is find the slope. And here they filled it all out for you. This is second y minus first y over second x minus first x. And they've even done the math. Okay. So now that we know the slope, we can choose one of the points and write an equation. Well, obviously they chose the smaller of the 2 points with the smaller values. We've got y, and the y term, or the y coordinate on that point is 61.25, and it is positive, so this is going to stay negative. And then the x coordinate is 5, which is also positive, so that's going to stay minus. And they filled in the slope for you here. Put the slope there. That's how you do that. Write down an S. Okay, taxis. The total cost of a taxi fare is given in the table. Determine the equation or equations in point slope form that models the situation if x represents the distance in miles and y represents the cost in dollars. So we're going to have to take 2 points. The first point we'll use is 1.5 and 6.90. And the second point we're going to use is 4, 1340. Okay? And we're going to find the slope. Well, that would be 1340 second y minus the first y over second x minus the first x. And I went ahead and did this in advance. This is 6.5, this is 2.5. And when you divide those out, you get 2.6. So our slope is 2.6. Okay? So right away, we can eliminate which one? D. D has the wrong slope. We can also eliminate another one because they've asked for the equation to be in point slope form, and I see a slope intercept form in this list. Yep, you guessed it. C is also out. That's slope intercept form. So the only possible correct answers then are A, B, and E. Well, like I had said before, the formula has minus signs here and here. The only time you will have a plus sign is if one of the values is negative, because then you get minus a negative. All of these values are positive. So all of the signs have to be minuses. So I know that E's not going to work no matter what, because these are both plus, which tells us that these numbers had to originally be negative, and they're not. So E's out of the running. But do A and B both work? Well, A uses the point 4, 1340. They put 4, the x value, where the x goes, and they put y, 1340, where the y goes, and they're both minus. So winner, winner, chicken dinner. But what about B? Well, B is using a different point. They're using this point. It doesn't matter. You can use whatever point you want. The x coordinate went where the x goes. The y coordinate goes where the y goes. They're both minus. We have another winner. So A and B were both correct equations to represent the data in this table. Now let's talk about standard form. I'm not a huge fan of point slope form with all those x's and y's. It gets a little scary, but I do like standard form. It's short, it's sweet, and it's very useful for solving systems of equations, which we will be doing shortly. So you get used to standard form. The rules with standard form are that A, B, and C are integers. They cannot be fractions, cannot be decimals. They must be positive or negative whole numbers. But in addition to that, A can never be negative. A can't be negative. B can be negative, C can be negative. A can't be negative. And A, B, and C can have no common factors. What that means is if you had something like 8A plus 4Y, or 8x plus 4y equals 6. This is not in fully reduced form because all of these numbers divide evenly by 2. So in order for it to be in the correct form, you would have to reduce it, divide each term by 2. Okay, now this would be the winner right here. Let me show you how you do this. All right, so they're giving you an equation in point slope form, and they're asking you to change it to standard form. First thing you want to do is get rid of the parentheses. So they're multiplying. No, that's not what you do. Sorry. In order to go into standard, I was going to the wrong form. In order to go to standard form, you need to get rid of this fraction guy. See, get rid of this fraction. So what you're going to do is you're going to multiply both sides by 5. Multiply both sides by 5 to get rid of that fraction. Okay? So that's going to give us a 5 here, and then we're going to have negative 2 here because this 5 is going to cancel. All right? Then multiply it out. 5 times y is 5y. 5 times negative 1 is negative 5. Multiply this side. Negative 2 times x is negative 2x. And negative 2 times positive 3 is negative 6. Right? Now we need this negative 5 to go over here, and we need the x to go over here. So, I mean, you can do it whatever order you want. They want you to add 5 first. So we'll add 5 first. And then we will have 5y equals negative 2x, and negative 6 plus 5 is negative 1. We're still not done, though, because this is standard form we want. We got to have this x over here. So then you would add 2x to both sides, and we would have 2x plus 5y equals negative 1. A, B, and C are all integers. A is not negative, and they do not share a common factor. So this is our fully reduced format. Standard form. Write down an n. Here they've given us an equation in slope-intercept form, and they want us to write it in standard form. Okay, not too much going on here. What we're going to have to do is get this x over on the left where it belongs, and we can do that by adding 7/2 to both sides. Well, do we want to do that first, or maybe we should get rid of that fraction first? I think we should probably get rid of that fraction first. Let's back up. Let's multiply both sides by 2. Get rid of the fraction. That gives us 2y equals negative 7x plus 10. Got to distribute. Okay. Then now we can add 7x to both sides. Don't worry, I'll do more examples of these. And we get 7x plus 2y equals 10. A, B, and C are all integers. A is not negative, and there is no common factor. Okay, so we're done with that. You did get that in, right? All right. Write in standard form when you're given 2 points. Okay, this is kind of a twisty, turny road. You've got to find the slope, write the equation in slope-intercept form, and then change it to standard form. That's why there's all this stuff, okay? So first thing they did was they found the slope. And they ended up with negative 7 over negative 14, which is positive 1/2. Okay, so we have a slope of positive 1/2. Then you're going to write the equation in slope-intercept form. Pick a point. They went with this one. And here's our slope. And you plug this into the slope-intercept form. The y-coordinate was negative 4. The slope is 1/2. The x-coordinate is positive 8. And we're trying to find the b. Well, we have negative 4. Half of 8 is 4 plus b. And then we subtract 4 from both sides, and we get b is negative 8. So the equation in slope-intercept form would be y equals 1/2 x minus 8. Now that we have that, y equals 1/2 x minus 8, we want to go to standard form. First order of business, let's get rid of that fraction. Okay, multiply both sides by 2. So now we have 2y equals, distribute. I know it's backwards distributing, but it works the same way. All right, now we have 1x, because 2 times 1/2 is 1, and half of negative 8 is negative 4. All right, now we want to put the x on the left-hand side. So we have negative x plus 2y equals negative 4. But Miss Williamson, you said that a could never be negative, and I meant it. We have to now multiply both sides of this equation, every term in the equation, by negative 1 to fix that. So this will become positive x, this becomes negative 2y, and this becomes positive 4. And that is the final totally reduced x minus 2y equals 4 is the total finally reduced thing. Perfect form. Yes. I'm happy. Select the equation in standard form for the line that passes through negative 9, 8, and 1, negative 12. Okay. Well, let's find slope. So we do second y minus the first y over second x minus the first x. This is negative 20 over 10, which reduces to negative 2. So we have a negative 2 slope. All right. And we're going for standard form. So the first thing we have to do is go to slope-intercept form. Which point do you want to use? How about 1, negative 12? Let's use 1, negative 12 for our x and y. This is our x, this is our y, that's our m. So we're going to go y equals mx plus b. Y is negative 12. M is negative 2. X is 1. And we're trying to find b. Negative 12 equals negative 2, because negative 2 times 1 is negative 2, plus b. Add 2 to both sides, and we get b is negative 10. So The equation in slope-intercept form then would be y equals, what was our slope? Slope was negative 2, x, and our b is negative 10, so we put minus 10. Now, this is easy. We want to go, there's no fractions to get rid of. We want the x on the left, so we do that by adding 2x to both sides. That gives us 2x plus y, you always write the x term first, equals negative 10. And there are no fractions, there's no common factors, and a is not negative. So, woo, that's a winner. Where do we see that one over here? It looks like D. Pretty cool. Just going to say. All right, now here's where it gets interesting, because now we're going to be talking about finding equations for parallel and perpendicular lines. Make sure you write down that T. They're going to give you an equation of a line, and they're going to say, write the equation of a line that passes through some point and is parallel to this line, or is perpendicular to this line. All right? What you need to know about parallel and perpendicular. Parallel means they have the same slope, same exact slope. If this line has a slope of 2, this line has a slope of 2. They just have different y-intercepts, okay? But perpendicular is interesting. It's even interesting to say perpendicular. Yeah. I almost never write that whole word out. Okay, perpendicular slopes are negative reciprocals of each other. I'm not sure if that's the exact terminology they use in the book, but I don't want to read all those words. Reciprocals. I don't think you do either. So for example, if you had a slope of 2, the perpendicular line would have a slope of negative 1/2. You have to visualize this as 2 over 1. You flip it and you change the sign. If you had a slope of negative 3/4, the perpendicular line will have a positive 4/3 slope. Okay. If you had a slope of 2/3, the perpendicular line will have a slope of negative 3/2. You flip them and you change the sign. Okay. That's basically what this page is telling you. And this page tells you the steps. So, you know, if you're working on this and I'm not there, these are the steps. They're in your book. You can look them up. It tells you exactly what to do. But the only problem is it tells you it in like math terminology, which sometimes is not the friendliest thing. But this is the steps for writing an equation for a parallel line. This is the steps for writing an equation that's perpendicular. The only difference is step 1. Because the first thing you have to do is figure out what the slope of the line that they've given you is. Well, if your line's parallel, it'll have the same slope. If your line's perpendicular, it'll have the negative reciprocal. Okay? I'll show you some examples. All right, example 7. Parallel line through a given point. So they're saying your line is parallel to this one and passes through this point. Okay? So the first thing we have to do is identify slope. Since we're looking for a parallel line, here's our slope right here, right? Okay, the slope of the original line is 3, so the slope of our line is also 3. We're looking for a parallel line. Now we can take this point and this slope and write it in point slope form, okay? Our y-coordinate is 2. I don't want to pause this. Okay, sorry about that. Phone call. All right, so we were filling in this stuff down here. Our point is negative 4, 2. So we take the y-coordinate and we write it here. We take the x-coordinate and we write it here. And our slope that we found goes here. All right. Now this needs to be simplified a smidge. This left-hand side's okay. But over here, we need to have 3 times x plus 4. All right. But they want it in slope-intercept form, not point-slope form. So now we have to distribute this 3. 3 times x is 3x, and 3 times 4 is plus 12. Then we have to get y by itself by adding 2 to both sides. And so we get y equals 3x plus 14. It's got some steps to it, doesn't it? Steps. Write down the letter A. This one will be easier because it doesn't have all that gobbledygook on the page that those other ones have. I don't like all that. Write an equation for a line that passes through 8, 2 and is parallel to the graph of this line. Okay, so that tells me that our slope is the same as that slope. Our slope is 3/4, but our line has to pass through the point 8, 2. So we're going to use point slope form because that's the chapter we're in. Yes. Okay, so we're going to start by putting, dang it, hang on a second. Sorry about that. I keep getting interrupted. Okay, we're going to start. Let's go ahead and fill in our framework. We know we're going to have y minus whatever the y coordinate is equals m, our slope, and then we're going to have x minus whatever the x coordinate is. Okay, so this is x, this is y, and that's m. We just fill in the blanks. Y minus 2, 3/4 for the slope, and the x coordinate is 8. Okay. Well, and they want, I think that they don't say what format they want, but since this one is in slope-intercept form, I think we'll assume they want slope-intercept form. And they wanted slope-intercept form on the last one. So we have y minus 2 equals 3/4 times x minus 8. All right, distribute, distribute. Y minus 2 equals 3/4 x minus 6. You would just do 3/4 times 8. And then the last step is to add 2 to both sides to get y by itself. And our equation is y equals 3/4 x minus 4. Do you see the similarity? The original line is y equals 3/4 x plus 2. See how similar these are? The slopes are the same, but the y-intercepts are different. Okay. Next. Now we're going to talk perpendicular. Same steps. The only difference is we're not going to have the same slope. We're going to have the negative reciprocal slope. And oh boy, I hate these pages when they have all this printing on one page. It's got to be horrible for you guys as kids too. Write the equation in slope-intercept form. Okay, so what we're going to do is subtract 3x from both sides, and they do this linearly, which I don't like. All right, subtract 3x from both sides. That gives us 2y on the left, and then over here we would have negative 3x plus 12. Then we divide everything by 2, and we get y equals negative 3/2 x plus 6. Okay, so the slope of the given line is, see, they gave it to you in standard form, so that's why we were fixing it, putting it in slope-intercept form so we could find the slope. Slope is negative 3/2, okay? The slope of a line that would be perpendicular to that is the negative reciprocal, or they call it the opposite reciprocal. So it would be positive 2/3. All right. So we know we have a line with a positive 2/3 slope that passes through the point 1, negative 2. So then we go back to our point slope formula. Is this fun or what? The y coordinate is negative 2, and the x coordinate is 1, and the slope is 2/3. Okay. We want to straighten this out here, make this y plus 2, and this is going to still be x minus 1. Then we distribute, and we'll have 2/3 x to get rid of the parentheses. 2/3 times negative 1 is minus 2/3. And then we're going to subtract 2 from both sides, and that gives us y equals 2/3 x minus 2 2/3. Yeah, because we had negative 2/3 and we added negative 2 to it, so that gives us negative 2 2/3. They couldn't make that easy on us, could they? Okay, so all the words are gone. I just breathe a sigh of relief when I get a problem like this. Okay, select the equation in slope-intercept form for the line that passes through that point and is perpendicular to the graph of this. Well, this is not in slope-intercept form, so we've got to fix this. I'm going to subtract x from both sides. That looks like a y. It's an x. Now it looks like a stick man. Which gives me negative 6y equals negative x plus 1. Then we're going to divide every single term by negative 6. Okay, so that gives me y equals, and this is a negative over a negative, so this makes a positive. And this is actually equal to 1/6 x minus 1/6. Okay. So if the slope of this line is 1/6, what's the slope of the perpendicular line? Negative 6. Okay, so now we know we have a perpendicular line with a slope of negative 6, and it passes through the point 5, 0. Now they want us to use point slope form, Okay, so it would be y minus the y coordinate, which is 0, equals slope, -6, times x minus the x coordinate, which is 5. Okay, now they're probably going to get rid of this -0. So they're probably just going to have y on the left and -6 times x minus 5. Do you have that over here? Y equals -6x plus, I thought they wanted this. Oh, they want it in slope-intercept form. Okay, my mistake. Slope-intercept form, we're going to have to distribute this. So slope-intercept form is going to give us -6x plus 30. Okay, that's what happened. All right, and that is A. Wow, I'm at 30 minutes already. Wow. Okay. Determine linear relations, determine line relationships. I warned you that this section was long, okay? Determine whether AB and EF are parallel, perpendicular, or neither, okay? So what they're giving you is they're giving you the coordinates of A and the coordinates of B, and you've got to find the slope of line AB. Then you've got to find the slope of line EF, and then you've got to decide if those slopes are the same and the lines are parallel, if the slopes are negative reciprocals of each other and they'd be perpendicular, and if they're not either one of those, then they're neither. They're just intersecting lines, okay? So they found the slope of AB. They filled in all the stuff. This gives us a slope of 3/4, and this one gives us a slope of 4/3, and this one's positive. And this one's positive because negative over a negative. So these would be neither, because what they've got to change sign for them to be negative reciprocals. The sign would have had to change, and the sign didn't change. They just flipped. So to determine whether the lines are parallel, compare their slopes. The two lines do not have the same slope. If they're parallel, they would have the same slope. They don't have the same slope. If they're perpendicular, then they would have negative reciprocals, okay? But, so, did I not get all this on here? Since the product of the slopes is -1, it's not -1, it's +1. So it would have to, these are neither. I'm sorry. They must have screwed up on this page. As they probably want it to be one or the other, but these lines are neither. 3/4 and 4/3. They're trying to trick you. They're trying to make it look like they're negative reciprocals, but one of these would have to be negative for these lines to be perpendicular, okay? And they're not. So this is a neither. Neither. But let's see how this one goes. All right, we want the slope of CD and the slope of KL, all right? Well, CD would be second Y minus the first Y, 12 minus 10, and second X minus the first X. So this is CD here. And that 12 minus 10 would be 2. And -1 minus 4 is -5. Now I need the slope of KL. And that would be -3 minus -5 over 1 minus 6. This would be +2 over -5. These have the exact same slope, so they are parallel. Okay. So complete each sentence given y equals ax minus 5 and y equals bx plus 3. Okay. If a is 4 and b is 4, then they have the same slope, so the lines are parallel. If a is -3 and b is 5, they're neither, okay? Because they're not the same and they're not negative reciprocals, it's neither. If a is -2 and b is +1/2, the graphs would be perpendicular. Oh, thank heavens. This video has gotten very long. I told you there was a lot of information in this section, though. Stay tuned, and I'll be right back with practice problems, and we'll have more fun and adventures. And in the meantime, go on over to McGraw-Hill and answer the secret word question. Good luck with that. See you in class.